Hi, this is Savannah Bingham and Dilsa Souffrant doing a Hardy-Weinberg problem. If 98 out of 200 individuals in a population express the recessive phenotype, what percent of the population would you predict to be heterozygote? I have given you information on the frequency of the homozygous recessive, or Q2. So start by determining Q2 and then solving for Q. Here we see that Dilsa is dividing 98 by 200 to get Q squared. This equals 0.49, or 49%. You then take the square root of 0.49, which equals 0.7, or 70%.
Now that we have solved for Q, we can easily solve for P by using the frequency of alleles equation, which is P plus Q equals 1. We subtract Q from both sides of the equation to be left with P equals 1 minus Q. From our previous problem, we solved that Q was 0.7, so we plug it in to have P equals 1 minus 0.7, which equals 0.3.
We know that P equals 0.3 and Q equals 0.7. Try to find the formula for heterozygotes. Think back to the Hardy-Weinberg equation. It is dealing with the genotypes of individuals in the population. It is P squared plus 2PQ plus Q squared equals 1. So you know that 2PQ equals the frequency of heterozygotes. Going back to the given equations and numbers, plug in 2 times 0.3 times 0.7, which gives you 0.42, or 42% heterozygote.
After finding our original answer for heterozygotes, which is 42%, and finding the homozygous recessive, which is 49%, we're going to go more in depth to find the homozygote dominant percent by using the Hardy-Weinberg equation of P squared plus 2PQ plus Q squared equals 1. Because we're finding the homozygous dominant, we're going to use P squared by plugging in 0.3, and because it's squared, we'll be multiplying it by itself, which equals 0.09 for a total of 9%.